Hi, I'm Robert Crowe, and today I'm going to be talking about ML engineering for production ML deployments, and specifically about TFX, the open source platform for production ML. Let's get started. First, let's discuss production ML and change. There are easy problems where the ground truth and the data change slowly, like months or years, or never maybe. So, for example, recognizing cats and dogs don't change very quickly. So, model retraining is typically driven by model improvements or better data or changes in the software or systems. Labeling is fairly easy for these kinds of problems. It gets a little more difficult when you're dealing in domains where the ground truth and the data does change, maybe on the order of weeks. And in this case, model retraining needs to be driven when model performance declines, as well as with model improvements and so forth. And labeling becomes more of a challenge in these domains. You can either use direct feedback from your systems if that's an option, or maybe crowd-based. There's a number of ways to apply labels. But it gets really hard when you have ground truth and data changing on the order of days or hours or even minutes. So situations like trying to predict markets or many real-time scenarios, this is a very difficult problem. And model retraining and declining model performance go hand in hand in these domains, and labeling really becomes a challenge. So it's these kinds of production ML scenarios which were the reason that Google developed TFX. Fundamentally, Google needed TFX because we have a ton of applications that use ML in production and mission critical applications. And you can see this across Google and actually across Alphabet. And you can see it in many of our partners as well. Twitter is an interesting case here because they actually came from a torch-based environment where they had a significant investment and moved to TensorFlow largely because of the availability of things like TFX. Here's a sort of a high-level look at what TFX is. On the top, you see tasks that are performed as part of the process of training a model. So you're ingesting data, and finally you have a trained model, and you're going to serve it. In the middle are libraries, and those libraries are also available as open source projects, and they can be used by themselves. But the components of a TFX pipeline leverage those libraries and create a pipeline for ML training and also for ML inference as well. This is sort of the canonical TFX pipeline. You could think of it as a hello world pipeline. In it, the orange components here are the standard components that come out of the box with TFX. But I want to emphasize that you are not limited to these. These are just where you start from. So we'll talk about each of these components. And on the right, we have the deployment targets that are available from TFX. So you might be deploying into a serving cluster in TensorFlow Serving, or a mobile application with TensorFlow Lite, or a JavaScript application, or into something like TensorFlow Hub if you're going to reuse that model maybe for transfer learning and later. So what is a TFX component? A TFX component is essentially a task that you perform in your ML pipeline. It has a configuration, and it gets its input from metadata. It's taking input artifacts from metadata, except for the very first component that's ingesting the original data set from some data source. It takes those inputs using an input channel, it does its task, and then it takes the result and creates a new artifact and puts that back into metadata through an output channel. And that's how components communicate with each other. An upstream component will produce an artifact that downstream components depend on, and data flows through the pipeline by flowing through these dependencies in metadata. So I've mentioned metadata. Let's talk more about the metadata store. Metadata in the metadata store powers some really significant functionality. First of all, it allows you to trace the lineage of artifacts that are produced. So for example, if you want to find out what data a model was trained with, it could have been trained months ago. You can trace that back by using metadata. You can also use metadata to compare previous training runs. So again, I may be retraining a model that could have been trained last months ago, and I want to compare those training runs to see why has it changed over those months. It also allows me to reuse previously computed outputs. A component and the tasks in machine learning can take quite a bit of resources and quite a bit of time to run, especially with large data sets and large models. So if the input to a component hasn't changed, I don't want to rerun that component. I just want to pull the last result from cache and reuse it. A lot of what TFX does is accomplished by distributing processing over a distributed cluster using Apache Beam. Apache Beam supports a number of different types of distributed clusters, including Apache Spark, Apache Flink, and Google Cloud Dataflow. And it supports a number of different languages through SDKs. So putting Beam in the middle, we have an SDK where we're going to make a call to Beam to define a Beam pipeline. That's going to get translated to the native API for whichever cluster we're running on, and a result is produced. Let's look at the TFX standard components. So again, this is the Hello World pipeline, and these are the standard components. But again, I want to emphasize you can create your own custom components, and there's 3 different ways of doing that. But let's talk about these standard components just so that they're clear. First off, we have to ingest our data, so we're going to use ExampleGen for that. ExampleGen is going to take our data, ingest it, split it, and save it off as TF examples in a TF record file. Next, StatisticsGen will make a full pass over that data and calculate statistics about it. That's important when we're in the part of the ML development process where we're trying to understand our data, or if we have a new data set and we want to see what's changed. SchemaGen then calculates a schema across our data. What are the types of each of our features? And for categorical variables, what are the valid categories? Example Validator takes both of those results and looks for problems. Things like examples that have the wrong type in a particular feature or a categorical value that shouldn't be there. Transform is where the feature engineering is done. And Transform will convert the feature engineering that we want to do into an input graph that becomes part of our model. Trainer takes that graph and the model that we've defined using TensorFlow and trains our model. Evaluator takes that trained model and does a deep analysis of the performance of that model. By deep analysis, I mean it's not just looking at the entire data set, it's looking at individual slices of the data to try to understand how performance varies across different parts of our data set. Infravalidator makes sure that we can actually deploy our model to our serving infrastructure. And if both Evaluator and Infravalidator agree that yes, we can deploy our model, and Evaluator has checked to make sure that the model is actually better than what we already have in production, then Pusher will push it to one of our deployment targets. And we talked about these: TensorFlow Serving, TensorFlow Lite, TensorFlow JS, or TensorFlow Hub. TFX also supports mobile and IoT deployments through TF Lite. So TF Lite support in TFX is used to train, evaluate, validate, and deploy TF Lite models from TFX pipelines. And there's really only 2 changes that you need to make. You need to invoke the TF Lite rewriter that happens from within Trainer, and then you need to evaluate that model using the TF Lite model for evaluation. I've mentioned a couple of times that TFX allows you to create custom components. Let's take a deeper look at that. First off, you can create a component by customizing the executor of an existing component. When you do create a custom component, it fits into your pipeline just like any other TFX component. And there's 3 ways to create a custom component: using a Python function, with a decorator and annotations for the arguments, or using a container where you can be implementing whatever task you're doing in whatever language you need, or extending existing component classes. TFX is also supported on Google Cloud using the Google Cloud AI Platform pipelines. Let's look at that. At a very high level, this is what the architecture looks like. TensorFlow is running on TFX, which in turn is running inside Kubeflow pipelines, and that's running on the Google Kubernetes engine, or GKE, and leveraging the Google services, the cloud services, managed services that are available on Google Cloud. At the end of the day, it's the same pipeline. Now let's take a look at 3 different ways to run a TFX pipeline when you're doing development. In the demo today, I want to show you 3 ways of developing with TFX. And to start with, we'll just create a complete TFX pipeline in a notebook, in a Colab notebook. And we won't actually get through the entire pipeline, but we'll get through the first few components, and the rest are very similar. So let's get started. I'm going to just jump over the explanation. This notebook, by the way, is available on the tutorials page of the TFX website. I've already run this once, so these things are preloaded so that we can save some time. Okay. Normally on the first run for this, you need to restart the runtime because of the way that Colab loads packages. So now we're going to import our packages. Okay. Let's check the versions, make sure they're good. Now, this is actually version 22. We just released version 23 this week. Set up the paths, and this is the Chicago taxi example. Okay, we've got a path to our data. That's what the data looks like. This is a CSV file. And now we're going to create the interactive context. So the interactive context is a key part of running in a notebook. Essentially what this does is it allows you to orchestrate a pipeline by stepping through notebook cells, and the interactive context maintains the context while you're doing that. So very useful for this kind of development. All right, and now we're going to run our first component, which is example gen. That's where we're going to ingest our data and split it. Okay, now at the end of each component, after you run each component, you'll see one of these. It's the Artifact Explorer, and it lets you explore the artifacts that were imported into the component and the resulting output from the component. So this is example gen, and I can look at the inputs that came through this input channel. And in this case, it's a external artifact. It's that CSV file, and the outputs. So the outputs are our split data set, and there's our split. We have train and eval by default. Okay, let's keep going. So now we're going to just take a look at the artifacts in a different way. That's just more of a Pythonic way to look at it. And we can look at individual examples that were ingested, and they look good. And so we're going to run our second component, which is statistics gen. Statistics gen is going to calculate statistics across our data set. We get, again, an artifact explorer for statistics gen, but let's keep going because there's a really nice UI for statistics gen that comes out of TensorFlow Data Validation, TFDV, and it allows us to really explore the statistics around our data set and our different features, including looking for the number of missing values and things like the valid categorical features. So really useful to be able to explore your data set. We're in the part of the ML development process here where we're really trying to set up our data and understand our data set. So let's move to the next one, which is schema gen. Schema gen tries to infer a schema from your data set. What are the types of your features? Now, you do need to think about making sure that it got it correct, because it'll make a best effort at doing that. But you may know more than schema gen does. So if things need to be adjusted, you can do that in the artifact that's produced by schema gen. Okay, we're going to stop there and move to the next style of development. Okay, the next environment we're going to look at is running locally on a desktop or a virtual desktop. We're going to be using Jupyter Lab with a notebook, and we're going to be using an IDE. So to start with, I've copied the Beam template into a folder on my system and started up Jupyter Notebook, which is open here. And let's go ahead and run through the notebook, at least the beginnings of it. One thing to be careful about, since I'm not running in Colab, I already have TFX installed in my virtual environment, so I'm not going to run this cell here. So we'll go ahead and set up some paths, check our version of TFX, which we've already installed previously, and set up some other variables and check our pipeline name and project directory. And then at this point, we're going to copy the rest of the template, the other template files, into our project directory. And we're using the TFX CLI to do that. So we'll go ahead and do that. And you'll see that I don't have CUDA loaded. So we see some errors around CUDA. That's fine. It's just telling me that I don't have CUDA. And then in the notebook context, we change into that directory. And then we can browse the files as sort of a sanity check and run some unit tests on our files too, which is always a good idea. Okay. So we've copied our template into the project directory. Now we're going to create a pipeline for the Beam DAG runner to run. Now we're not running it yet, we're just creating it. Okay. So actually it's telling me it already exists because I ran this once before. So now we're going to run our pipeline. So again, using the TFX CLI here, you can see that right here, and we're using a run command. So at this point, the only component we have in our pipeline is the example gen, which is in this case reading from a CSV, and you can see it's finished. Okay, so now let's move on. And we'll add some components. So to do that, we can do it a couple of different ways, but I'm going to go into an IDE. I've got VS Code running here, and these are the files we're working with. This is actually the template that we're running in Jupyter Lab. So I could be running all of this in VS Code too. But where I want to add those templates, those components, is in my pipeline file. So I'm going to edit pipeline.py. And you'll see the way this is structured, it's really easy to create this first sort of hello world pipeline using the Chicago taxi example. Example gen is already part of the pipeline. Statistics gen is defined, but it hasn't been added to the pipeline. So all I have to do is uncomment that to add statistics gen. And let's add a couple more. Let's add schema gen and example validator And let's add transform because we want to do something here with transform. So I'm going to save that file. And in transform, there's some user code that we're going to be using, and this is where we do our feature engineering. So there is a function in our preprocessing.py file called preprocessing function that's given to the transform component, and transform runs that to do preprocessing or feature engineering on our data set. So what I'm going to do here is set a breakpoint there, and then I'm going to run the Beam DAG runner here. So I'm going to go to the debugger, and I'm going to start up the Beam DAG runner. No, I'm sorry. Wait, I have to update the pipeline first. So this command right here, I'm going to run. And in fact, I'm going to comment out the run command so that I'm only doing the update. Otherwise, it would run it twice, and that's fine, but I don't want to do that. So we'll go ahead and run that. It'll update the pipeline for me, so it's going to add the components that I just added, which are statistics gen, schema gen, example validator, and transform. Okay. So now, if I run the Beam DAG runner in the debugger, it's going to run my pipeline. And it's going to hit an error that I caused when I edited the file, which is okay. So that's all right. We'll stop that. We'll edit our file. And it was complaining about one of these here. Oh, I need to edit pipeline.py because that's where, yeah, I got an S from just bad typing. So let's save that, and we'll rerun Beam DAG runner. And there we go. We hit our breakpoint. And we have variables here that we can inspect, including our features. So for doing IDE style development, you could actually do it in a notebook or the IDE or both. This is pretty handy. Okay, the next style of development that we're going to look at is on Google Cloud, where we're using Cloud AI Platform pipelines to run a TFX pipeline. And this is running actually on top of Kubeflow pipelines. So you have, in this case, a Jupyter Lab instance that you're going to use with a template that's very similar to the template we just looked at with the Beam orchestrator. Not like the interactive context we looked at first, but the Beam orchestrator, where we're setting up our components and then we run our pipeline. So very similar. We're using the CLI down here to first create our pipeline, and then when we make changes to our pipelines, we kick off an update and then a run using the CLI. So very similar process. And again, you have the same sorts of files. They're here in my project directory. So the pre-processing function is just like we looked at just now in Beam, although I can't set breakpoints in Jupyter Lab. And I add and subtract components here in pipeline.py, just like we did previously. So we have that environment, and we also have Kubeflow pipeline. So this is the notebook that we're using. That's the template that we just looked at. We can also look at our pipelines in a graphical view to see how things are put together. And we can also look at experiments in very much the same way. So there's an experiment that we've run, and you'll see it's been marked as successful. We also have artifacts that we can look at, and there's a nice tool here that allows us to look at the lineage of artifacts and understand how they flow, how the data flows through our pipeline. So a lot of great tools here on Google Cloud. I encourage you all to look at it. I know this was really fast, but hopefully this was useful. And that's TFX. It includes standard components for your production needs, and you can also create your own custom components. It's flexible at several layers, including orchestration and metadata. We also have a new blog post out that explains the history of TFX, TensorFlow Extended. I encourage you to take a look. And here's our website if you haven't seen it before. And here's some links to help you get started. And that was a really quick overview of TFX. There's lots more on the website. If you need to put an ML application into production, I strongly urge you to take a look at TFX. It's what Google uses. Thanks for watching.